Hey guys, so about a year ago I went ahead and bought the LaMotte BrewLab system in order to test my water. Now, I tested it a couple times a year and sort of see how it changes over the course throughout the year, because I think that spring is probably a little bit different than fall, and fall is probably a little bit different than the middle of the winter. So I went ahead and recorded some of these steps. I want to go ahead and share that with you. So I think it's kind of important if you want to understand more about your water, you want to understand more about things like what is the hardness of your water, how much sulfate is in there, how much sodium is in there. So without further ado, let's go ahead and get started. I'm going to show you what's in the kit, and then we're going to walk all the way through it. So here we go, the LaMotte Brew System. Inside it, crack it open, and we've got the BrewLab sheets and the how-to guide and the various chemicals necessary to test the water. So let's go through them. Okay, so here's everything that's included inside the LaMotte water test kit. We've got 3 tubes for testing the water. We've got a hardness tube for testing the water hardness, of course. We've got a dripper. Also, we've got hardness number 5, tablets number 6, and hardness number 7 for testing the water hardness. Coming over for testing the sodium hydroxide and the calcium hardness, for testing the magnesium hardness. Next over here we've got the sulfate tablets, the sulfate gauge chart, if you will, and also the silver nitrate in order to test that. Moving along, we've got testers, the chloride A, total alkalinity indicator, and sulfuric acid. And these are all of the components necessary in order to test your water for getting accurate values for hardness, magnesium hardness, chloride, sulfate, total alkalinity, residual alkalinity, and sodium. So let's go ahead and get started and test our water for hardness first. Okay, so I've got my sample of water here. I've got about 1 liter of water in my flask. The instructions are over here. These are the ingredients that are going to be necessary in order to test for hardness. And the way that we're going to do this is we're going to take this small test tube here, the hardness tube, and we can fill it to either 10 parts per million or the 20 parts per million site. So upper or lower. And then we're going to take and add 5 drops of the hardness agent, number 5, and swirl it. Then we're going to add 1 hardness reagent tablet and swirl it to dissolve the tablet. If it turns red, then the hardness is present. If it is, proceed to the next step. If the sample is blue, then the total hardness is 0 parts per million. So if it turns red, then we got to determine how much of the hardness we have. So then we'll hold the hardness reagent 7 vertically to add 1 drop at a time, swirling and counting after each drop until the color changes completely from red to blue and remains there for 30 seconds. Then we'll brush and rinse the tube, but using the number of drops, we're going to multiply the number of drops. If we use the upper line, we'll multiply it by 10. If we use the lower line, we'll multiply it by 20. And then that will be our total hardness. Okay, so for the first experiment, you can see that I've topped this up to the 10 parts per million line. And I'm going to go ahead and do the first step of adding in 5 drops of the hardness number 5 solution. So here we go. 1, 2, 3, 4, 5. I'm going to go ahead and just swirl it up a little bit to mix it. Next, it's going to be to add in 1 of the hardness tablets, number 6. Here it is. So let's go ahead and put that in. And just to stir it up. If it turns red, then the hardness is present. If it turns blue, then there is no hardness. I can see it's already turning red. It's actually more like a violet. kind of interesting. So this next step is going to be about adding in the hardness number 7 solution, and we're going to be swirling it and dropping it in and waiting about 30 seconds in between each one and see if it turns blue. When it turns blue, then we'll have to count the number of drops that we used. So let's go ahead and do this. That'll go in the sideways. There's 1 drop. See if that turns it blue at all. And put in 1 more drop. There we go. It's looking a little bit more purple. I'm going to go 1 more. Now it's turned blue. There, you should be able to see that. And it should stay blue for 30 seconds. So I used 3 drops at the 10 parts per million marker. It's really dark blue. Alright, let's get a really good look at that. You can see how nice of a brilliant blue that is. Very distinguishable, very distinct. Easily to pick that out from the purple that it was. So based on the calculations, take the number of drops that it took to convert it to blue, and I used the upper line, times that by 10, and that gives me 30. So that means my water hardness is 30 CaCO3 parts per million. It's a little bit low for like IPAs and stuff, but actually really good for other lighter beers. Alright, next we're going to go ahead and do the calcium hardness. For this one, we're going to fill up one of the tubes to one of the lines. I'll use the upper line again. This time we're going to add in 6 drops of sodium hydroxide reagent and swirl it to mix it. And then we're going to add in 1 calcium hardness tablet and swirl to dissolve that. And then we're going to go ahead and check to see if it's red or if it's blue. Okay, so I've refilled my hardness tube water sample up to the 10 parts per million line. I'll go ahead and set that down. Now it's time to add in 6 drops of the sodium hydroxide solution. So here's the sodium hydroxide solution. I'll go ahead and add in 6 drops. One, 2, 3, 4, 5, 6. Next, we're going to add in 1 of the calcium hardness indicator tablets. That's one of these right here. Here we go. Let's go ahead and add this in. Next, we're going to go ahead and swirl it until it changes color. There it goes. It's turning like a dark violet, reddish violet. It really like a deep purple. So it's not really blue, so I can't, just ignore it. So I'm going to go ahead and proceed to the next step. So the next step is to go ahead and do the same procedure with the hardness number 7 reagent. So let's go ahead and add this in. Count each one. It's 1 drop. Just swirl it. There it goes. It's starting to turn blue already. So, but it has to change and turn blue and stay blue for 30 seconds. Now it's actually going a little bit back to violet. It's more like a blue or violet than a real blue. Alright, so I'm going to go ahead and proceed with drop number 2. go. Drop number 2 is in. It's turning blue. Alright, so there we go. It only took 2 drops to get to a really nice deep blue color. And so, according to the charts, it says multiply the number of drops by 10 again. So this time we get 20. And this will be recorded as calcium hardness. Now, in order to convert this to calcium levels actually in the water, multiply it by 0.4. So 0.4 times 20 is 8. So I've got a count of calcium 8 parts per million in the water. In order to get magnesium hardness, it's going to be the total hardness, which was 30, minus the calcium hardness, which was 20. That gives me 10. So that's 10 magnesium hardness. In order to convert that to magnesium, multiply the test result by 0.24. So that would be 10 times 0.24, and that would equal 2.4. So I've got magnesium level of 2.4 parts per million in my water. Next test, chloride. Let's figure out the chloride. So we're going to go ahead and fill up one of the other test tubes with sample water, and then we're going to add 5 drops of the chloride reagent A, and then swirl it to mix that in. Then we're going to use the silver nitrate in order to add 1 drop at a time in order to observe a change in color. So let's go ahead and do that now. Alright, so for this test, I'm starting to use the 0715 tube. I've got it filled to 25 milliliters. And the reason why I use more water rather than the lesser option is, I don't know, I feel that more water will give me more accurate results. I could be wrong about that, but that's just me. So now what we're going to do is we're going to add in 5 drops of the chloride reagent A and swirl to mix that in. So let's go ahead and do that. 1, 2, 3, 4, 5. Swirl it up. Get it all mixed in there. Great. Now we want to add in the silver nitrate using the same procedures as before. 1 drop at a time, swirling it and counting how many drops it takes to change the color from yellow to orange brown and stay there for 30 seconds. So let's go ahead. Start with 1. 1. Ooh, got some change immediately. Let's go ahead and swirl that around. We're looking for orange brown. That was 1. It looks like it's been absorbed. It's not changing. So I'm going to go to 2. There's 2 drops. It looks like it was absorbed again. Three drops. There we go. That's definitely taken on a different characteristic. 3 drops to get the orange brown. Now it looks like it's staying there. It's got to stay for 30 seconds. So I'll give it a chance. It's like a kind of like a very light pale ale. Well, a pale ale. Alright, let's see what 1 more drop does. So that was 3. I'm going to do 4 just for kicks. See if it gets any darker. Oh yeah, because it's definitely getting darker. More orange brown. that's probably what I was looking for. Orange brown. That's more somewhere like blood orange. I'm going to call that 4. The pale ale sort of color was almost there, but not quite orange brown, but 4 definitely put it orange brown. There we go. So there we go. Looking at the instructions, using 25 milliliters, multiply that by 10, that will give me 40. So that would be 40 parts per million of chloride. Next test will be the sulfate test. For this test, we're going to go ahead and fill up the clean test tube to 5 milliliters of water, sample water. And then we're going to add in one of the sulfate turb tablets. And then we're going to go ahead and cap it and shake it until the tablet disintegrates. And then we're going to use this chart in order to determine where the color is on the chart. Let's do that now. Okay, so here's my sample of 5 milliliters. Here's my tablet. So I'm going to go ahead and drop that in. I'm going to put the cap on it. I'm just going to shake it up until it dissolves. Come back when this is done. Okay, so the idea here is to take the sample now that the tablet has dissolved and place it over the target, and looking down, match it up to the sample on the left. Now continue to move it up until it looks like the sample on the left. When it gets there, then we've reached our parts per million of sulfate. This is looking pretty close to the 0. So 0 sulfate in my water. So the next test is the total alkalinity test. For this one, we're going to fill up another test tube to 25 milliliters of water. We're going to add in 3 drops of the total alkalinity indicator solution. Swirl it to mix it in until it turns green. Next, we're going to add in sulfuric acid, 1 drop at a time, swirling and counting after each drop until the color changes completely from green to red and remains there for 30 seconds. So let's go ahead and do that. So here's the tube filled to 25 milliliters of water. And I'm going to put in 3 drops of the total alkalinity indicator, swirl it to mix it to green. 3 drops. 1, 2, 3. It's more like a bluish green. Sort of grassy green. A little bit, not so much. Okay. So next we're going to take the sulfuric acid, and what we want to do is observe it changing from green to red and staying there for 30 seconds. How many drops? Here goes 1. There's 1 drop. Oop, it almost cleared there for a second. Let's try 2. Oh, almost. You see that? And it changed back. Let's try 3. 3 drops. And that was the 3rd drop. Ooh, there we go. That was it. 3 drops. Now it needs to stay there for 30 seconds. Okay, I'm pretty convinced. We'll let that stay a few more seconds and come back. Okay, so it only took 3 drops of the sulfuric acid to turn the solution from green to red. It's remained red now for a couple minutes. Now, taking that from the 25 milliliter mark, multiplying that by 10 gives me 30. So that will give me a total alkalinity of 30 CaCO3 parts per million. If I want to get the HCO3 from that, just multiply it by 1.2. So that will give me 36 HCO3. 36. In order to use these figures to calculate the residual alkalinity, and this is probably one of the most important ones for your water adjustments, is to take the total alkalinity, and I believe this is a minus here. And then what we're going to minus is that total alkalinity, which was 30, from the calculation here. The calculation is take the calcium hardness, and the calcium hardness I had before was 30, and I'm going to multiply that by my magnesium hardness times 0.5. My magnesium hardness was 10, so that's going to be 5, so that's 25 total. And multiply that by 3.5, and that gives me 7.142. 7.142. So that gives me 7.142 minus from the total alkalinity, which again was 30. So that leaves me with 22.8 CaCO for my residual alkalinity. Next, time to figure out the sodium. Okay, so figuring out the sodium. In order to get the sodium, we have to use the other 5 ions to figure out the 6th one. So since the water has a neutral charge, the total number of negatively charged anions must equal the total number of positively charged cations. 6 ions typically make up 98% of the total ions, so the sodium concentration can be estimated by testing for the 5 other ions. So we're going to take chloride, my chloride values, divide them by 35, add that result to sulfate values divided by 48, and then add that value to the alkalinity multiplied or divided by 50. And that will give me A. Then I'll take my total hardness, that will be B. My sodium, therefore, becomes A minus B times 23. The thing that bothers me, though, is the alkalinity. Here it doesn't specify whether or not it's supposed to be total alkalinity or the residual alkalinity values. So I think I'm going to have to consult the water book here in order to find out for sure which one they're talking about here. But for the sake of this exercise, I've sort of used a couple of them, both of them actually. In one case, I came out with, I was using 22.8, and that was my total alkalinity. No, sorry. So in one case, or I'm going to use them both here just to figure it out, sort of get a range, but the residual alkalinity came out to be 22.8, but the total alkalinity was 30. Right? In order to get the residual alkalinity, there was a smaller calculation down here at the bottom of the page. So I'm going to use over here, so for my chloride it was 40, I'll divide that by 35 to get 1.14. Sulfate was 0, comes out 0. And then for my alkalinity, I'll take both 22.8 and 30, divide that by 50, and I'm going to get for one 0.456, the other one 0.6. So that will become A. By adding these 3 things up, I'm going to get 1.596 or 1.74. For my positive ions, I had a total of 30 total hardness. Divide that by 50, and I'm going to get 0.6. So B becomes 0.6. And therefore, in the 2 different ranges, A minus B is either going to be 1.596 minus 0.6 or 1.74 minus 0.6, and then divide that, or sorry, multiply that by 23, and that gives me either 22.9 or 26.2. So that's going to be my sodium range, somewhere within those values. So that's about it. Taking these values from everything we've tested inside this book, you should be able to plug that into Beersmith or any other water calculation software or spreadsheet in order to determine what your salt addition should be for your target water profile. The only thing left to do, of course, is to check your pH, and that I do on brew day, since it changes, and I generally calculate or calibrate my pH meter before every brew. So that is the LaMotte BrewLab Water Analysis Homebrewer Kit. Okay, so there you go. There's really not a lot to it. The chemicals that they provide, all of the capsules, you know, it's all compact, it's very easy to understand, and I thought it was great. You know, you get probably, I think it's anywhere between 50 to 80 uses out of it. The capsules, I think there's at least, the least amount is 50 capsules, so you can test it as many times as you like. It's going to last a while, no doubt about it. I know there are other systems out there now, more electronic, more automated systems, you know, talking to your phone and whatnot, and maybe one day I'll get around to investing in one of those and trying it out, but this is sufficing for right now, and yeah, it's doing just fine. So with that, I hope you guys enjoyed the video. Cheers.